Hello, in this video we want to look at groundwater and aquifers, and we'll touch on some karst topography at the end. So to start with, groundwater is just water that is seeped into the ground. Real creative on the naming. And it soaks in and fills up all of the voids in the soil and in the rock. And so we end up with what's called the water table here. What that is it's the line where below that all of the voids in the soil and the rock are completely full of water. So there will be some water above that water table, just in the soil and in the rock, but it's not completely saturated. The voids in the soil and rock is some of it's air, some of it's water. So below that, below the water table, all of those voids, or almost all of those voids, are filled with water rather than air. And so a little bit more about the groundwater. It can come out of the ground through springs and into lakes and rivers, and it can be pumped out by humans with wells. And it only gets recharged by precipitation, and snow melt, and seepage. So like seepage from either other reservoirs or like runoff from irrigation, where the water doesn't get completely used or evaporated and it seeps back down into the ground. Now we'll talk about these aquifers here just a little bit. Again, in this graphic we've got the water table, and an aquifer is just an area where there is layers of rock that is permeable to the water. So that's either the rock itself, like it's solid rock that can let the water flow through, or it's fractured rock, sand, and gravel that will still allow the water to pass through it. And so we end up with a whole area of this rock, whatever kind it is, that is completely saturated with water, and the water can move and flow through it. And so when we drill a well down into an aquifer, we just need to be below that water table so that as we pump water out, it flows in from the surrounding areas, flows through the rock, and we can keep pumping the water. It refills around the well. There are a few different kinds of aquifers based on how deep they are and how confined they are. So this kind of upper level aquifer here, all of this around it can flow water. And there's there's always, but sometimes depending on how deep you have to go, there's a confining layer, usually either clay or a non-permeable solid rock, so that the water can't seep down anymore. That's what allows this to fill up and completely saturate above that. And then sometimes there's a confined aquifer where we've got the upper aquifer and then that confining layer, but below that there's another layer of water permeable rock where we get another aquifer, and then below that there'd be another bed confining that. If we drill a well down into those confined aquifers and the conditions are just right, sometimes they're under pressure, and so they will flow to the surface all by themselves with no need for equipment or pumps or anything. It's got to be fairly special circumstances. Just drilling down through a confining layer and into one of these confined aquifers doesn't mean that it's going to flow. And they're usually called artesian wells. Whether they flow by themselves or not, the flowing is just a special kind. So artesian wells are just drilled into a confined aquifer. And if the conditions are just right, if you are deep enough and below just depending on the geography around, if you're below this level here, the water will flow out all by itself because the water down here is under pressure and it gets pushed out of the well and flows all by itself. Aquifers in the U.S., they're kind of everywhere, some bigger than others and some with different characteristics depending on what type of rock makes up the aquifer. We've all heard of the Ogallala aquifer here, mostly sand and gravel. But there are aquifers all over the country made up of different types of rock. And one thing it's worth noting that there is groundwater pretty much everywhere. Some aquifers are just larger than others. But just about anywhere you can dig down and find groundwater with the well. Getting on to this karst topography that I mentioned, sometimes if the makeup of the rock is just right, then precipitation will pick up CO2 and make a weak carbonic acid, and it will erode some of the rock as it flows, and it'll seep in and it'll dissolve some of the limestone usually. Sometimes these others, though, gypsum and dolomite, can also be dissolved by this weak carbonic acid, and so small fissures in the rock will get dissolved away, and they'll become larger and larger over time, and we end up with underground caves. And if an area um, underneath some other rock gets eroded away, dissolved and eroded away, then we actually end up with a sinkhole. If all of that supporting rock gets dissolved, then the layers above can sink down. A couple of pictures here. One of them is from the Ozarks, and it's an example of a cave formed by this limestone being dissolved by the weak acid. And there's tons of pictures online, especially of these caves in the Ozarks, and they can be absolutely huge or they can be tiny. On the right is a picture from China. These are above ground formations, but formed the same way, just through limestone being eroded by that weak carbonic acid. This last part where it says surface streams are usually absent in an area that has karst topography, the next graphic will kind of show us why that's true. And so we've got an area that's got a lot of limestone in it, and so the water, when it seeps in, it finds all those cracks and fissures and opens them up as more and more of that limestone dissolves. And so we can end up with these underground caves, and you can kind of picture if the water is flowing in through the cracks, and then more and more water flows, and the cave gets bigger and bigger. Sometimes that's when we get either a complete cave in or just a sinkhole where the upper rock, whether it's limestone or another rock layered on top of it, kind of sinks into the ground. And then as we get into the bigger and bigger caves, sometimes we get these stalagmite and stalactite formations where the water seeps out of the rock and drips and leaves behind some evaporites, and that's how the stalagmites and stalactites are formed. What I was talking about on the last slide with the streams disappearing, sometimes you've got a surface stream that then makes it to an area with this kind of developed karst topography, and so the stream will completely disappear underground. It'll make its way into these underground channels and caverns, and you'll end up with just this underground stream, and you can no longer see it, and it reemerges later on as a spring. It's really worth kind of looking at some of the examples of karst topography because it's really quite amazing. Some of these underwater rivers, you can actually take tours of them. You can go on the boats in the underground caverns, and you can go on boats on these underground rivers. And just some of the formations that get formed both below the ground and above the ground are pretty amazing to look at. This map is just an example of where you might find this karst topography. You can see that it's pretty widespread, but kind of hard to see these. I'll try to link to a larger map if you want to look closer. But the dark blue here is where you've got that carbonate rock closer to the surface, so you're more likely to see these caves and above ground formations. Then the others are different types of rock that can be dissolved by the carbonic acid, and the different colors depend on how deep it is for each type of rock. So it's possible to find it most places, more common in rainy environments. So that's karst topography. It kind of fits in with this idea of groundwater and aquifers because it's formed by this movement of water. It's worth noting, I said that water can flow through all of these aquifers. Like the rock is permeable enough that water will actually flow, and that's how it gets back into the streams and rivers. And typically in an aquifer, it flows very slowly because it's got to make its way through this rock. But in an area with a lot of karst topography, you can end up, the water flows much more quickly, and so the water underground can move a lot farther, a lot faster, and so pollution becomes more of an issue. Also because it's moving faster and farther, but it's not being filtered as much either by having to pass through all of these different channels in the rock. Okay, so that's kind of the basics of groundwater and aquifers. Um, Most important things to remember is that these aquifers are not just huge underground lakes. They're just different types of rock that are completely saturated with water, and so the water can flow through them, but it is still a solid kind of weight-bearing layer. Typically, an aquifer is not just a open space underground.